Alright guys, so now we're going to look at inscribed angles. The formal definition, as it says here, is an inscribed angle is an angle that is formed by two chords that share an endpoint. Or basically, an inscribed angle is made by any 3 points on a circle. So like for this first example here, you'll see these in two ways. This first example, we have points A, B, and C, and as you can see here, it makes an angle. So instead of going through the center, they don't, and they go around and make an angle. So there's going to be two different kinds of these. This first one, as you can see, it's not made by a diameter. So basically what I mean here is like none of these points go straight across and they meet our third point, so it doesn't involve the diameter. That's what's happening in this, is that our angle is made by 2 points that form a diameter. For this first rule, what we have is the measure of our arc, or measure of angle ABC, so measure of this angle right here, is equal to half the measure of arc ADC. So that angle is half the measure of that arc. Okay, so basically in general, the inscribed angle is half the measure of the inscribed arc. Okay, so that's one instance. This second one, as we saw, is kind of a special case because that angle is made by 2 points that form a diameter. Okay, so basically this rule, let me put this in a different color, why not? Basically an inscribed angle of a semicircle is 90 degrees. The reason being is because that angle formed by ABC, it needs to be half of that arc, but that arc, since it's a semicircle, is 180 degrees, so we know it's going to be 90. So that's a special case of the one above. Okay, so let's practice this. So we got a lot of different examples here. So for A, it says we want to find the measure of the missing arc or inscribed angle. So we want to find this, which that's our inscribed angle. And we just saw that our inscribed angle is half of the inscribed arc. So basically, that angle is half of that arc, and we know that arc is 174 degrees, so we can just take 174 divided by 2, and that gives us 87 degrees. So our missing angle there is 87 degrees. Okay. All right. So now for this one, we kind of got to go chasing our degrees here. We're chasing our arc. So we're wanting to find this arc right there. Okay. So we have this inscribed angle, which is 50, and that corresponds to this arc right there. And so because this angle is 50, means that this arc is double that. So basically it's 50 times 2, which is 100 degrees. So we know that arc is 100 degrees, but even bigger here, this whole arc, what shape does that make? A semicircle. And a semicircle measures 180 degrees. So what we can do is we can take 180 and subtract 100 from it, which gives us 80 degrees. So our missing arc is, excuse me, 80 degrees. Okay, so let's keep on chasing with C here. Okay, we want to find this arc right here. To be able to do that, we're going to need to find what this arc is right there. That's an inscribed arc of angle GFH. So we know that the blue arc is double the green angle. So we just got to take 84, multiply it by 2, which gives us 168 degrees. So now this arc right here is 186 degrees. And now, to figure out what our missing arc is, what are the total degrees in a circle? 360 degrees. So what we can do is we can take 360 and subtract 60 and 186. So subtract 60, subtract 100, and that's not, oh, why did I write 186? I'm silly. That should be 168, because that is what we found right here. So we'd subtract 168, and that gives us 132 degrees. Ta-da! All right. So now we get some fun stuff coming up. This D here looks kind of trippy, but we got this arc, this blue arc we know is 96, and that corresponds to that angle right there. But maybe that doesn't even matter, because this arc, that blue arc, forms a semicircle, or is part of the semicircle formed by that green diameter. And a semicircle is 180 degrees. So to figure out what, let me kind of erase this here, what that part of that semicircle is, we got to take 180 and subtract 96, and that gives us 84. So now this missing arc is 84 degrees, but that arc is made by this inscribed angle. And remember, the inscribed angle is half of whatever our inscribed arc is. So we can take 84, divide it by 2, and that gives us, dun dun dun, 42 degrees. So our missing angle is 42 degrees. So this, guys, is something I like to call angle hunting. So we just got to look at our circles and hunt for the angle that we're trying to find. As always, let's make it a little bit more complicated and introduce some variables, some variables into this. So now, this says we want to find the measure of angle x, or zxy. So we want to find z to x to y. That angle right there. Okay. So this x plus 99 corresponds to that angle. And this over here, this 4x plus 6 corresponds to that arc. And we just learned that that inscribed angle, or that inscribed arc, which measures, I'm going to go into blue, 4x plus 16, that is equal to twice what our inscribed angle is. So we take our inscribed angle, which is x plus 19, and multiply it by 2. Now we plug, now we need to chug and refuse to do drug. So to do that first, we distribute the 2. So we get 4x plus 16 equals 2 times x is 2x, plus 2 times 19 is 38. Okay. Now we can subtract 2x. Subtract 2x. So that gives us 2x plus 16 is equal to 38. And now we can subtract 16. So that gives us 2x is equal to my favorite number, 22. And now to get x by itself, we divide by 2. So now, and so that gives us x is equal to 22 divided by 2 is 11. So, but that gives us what x is. That doesn't give us what our angle is. So we have to take that 11 and plug it in for x for what our angle equation was. So the measure of angle zxy is equal to 11 plus 19, which is equal to 30 degrees. Ta-da! Okay. Another way you're going to see this get a little bit more complicated is that now we want to solve for the measure of MKL. So the measure of MKL we want to solve for, so we got to figure out how we can do that. But notice so one thing we have to notice that now where's my tool? So notice that MK is a diameter. So that means MLK is 90 degrees because that's a special case. So we know that that angle right there is 90 degrees. So now we have to figure out what x is in order to be able to help us solve this. So, but since MK is a diameter, that means that this arc made right here is a semicircle. And what's true about semicircles? They equal 180 degrees. So what we can do is we can take (3x plus 1) and 2x plus 9 and add those together, or 13x plus 1 plus 21x plus 9, and that's going to be equal to 180 degrees. And now we combine like terms. So we got 13x and 21x. That gives us 34x. We got 1 and 9, which gives us 10. And that's still equal to 180. Okay. Now we got to move the 10, so we subtract the 10. Subtract 10. And we get 34x is equal to 170. And so now to get x by itself, we can divide by 34. I'm use a different color just for sake of using different colors, and it makes it look pretty. Divide by 34, divide by 34, and that gives us x is equal to 5. But that's only part of the puzzle on this one. Reason being is because we have to figure out what that red angle is. So to be able to do that, let's find out what this arc is. Because that inscribed arc is made by the inscribed angle. So we gotta take our x and plug it in. So we got 21 times 5 plus 9. 21 times 5 is 105. Then we got to add 9, which gives us 114. But that's the measure of the arc. We need to find the measure of the angle. But remember, the arc is 2 times the angle, so we can just take our arc and divide it by 2. Which gives us, 57 degrees. And voila! Now we found it. Alright, so that's all we got for this lesson, guys. So please, if you didn't understand something here, please pause, please go back, ask your friends. Please come and see me if you need anything, and best of luck.